Hi there. Wanted to chat a little bit about Module 6. In terms of mathematical thinking, I wanted to share with you a couple of ideas. One, if you are ever in a building and you are working with grade 5, 6, 7, 8 students or younger, there are kits for teaching different things by a person named Kathy Fosno. That when you look at her, she calls it her landscape of learning. It's very big and might look confusing and intimidating. But if you look at the actual kits for lessons, there are these big boxes of a few lessons. They're amazing. And the reason why they're amazing is because this woman and her team really create these lessons treating children as if they were young mathematicians. So it gives you little tips and tricks about how to even talk to the kids. For example, her lessons really want you to, when you're talking to students, to be at their same eye level. All right, so if they're sitting on the floor, you're sitting on the floor. If they're sitting at a table, you're sitting at a table with them. And this is because it really instills the idea that we are all mathematicians. We have a mathematical community, and we all need to put out our ideas because they're all valuable. Working with her ideas, and I actually got to do a few podcasts with her in the past, and so talking to her really changed my perspective on the idea of treating students as if they were mathematicians. Because if I set those high expectations, they really do rise to the challenge. I'm also going to post here a link that summarizes Peter Liljedahl's work on building thinking classrooms. It's a sketch note. It's really good because I think that this module, it really helps to summarize the thinking of this module. And so the way that his classroom functions, I don't know if I've talked about it before, but you do your visibly random grouping like I talked about in the last session. And so you have little groups of students and they're working on a bigger problem around the classroom, right? So everybody's kind of standing at a part of the blackboard or whiteboard or even working on windows or whatever. It requires students to be standing so that the entire class can see each other's work, right? Because you get cross-pollination. And it's a bigger task always. It's a bigger task always. So students are off working, and the requirement is that I set a minimum bar for students to cross before I'm willing to intervene as a teacher. And so when I say that before I'm willing to intervene, it means that I'm not going to talk whole class, right, until everybody's reached this bar. I'm hopping around group to group to make sure that everybody gets to that level, but I'm not going to interrupt until they get there. So that ensures that everybody's at a certain level of thinking, right? And then I'll let them continue working. I'll give you an example of a question that I've asked in a vertical classroom that really worked. So I will say there's a ball in a box, and I would like to know how much empty space there is in that box. And that's all I'll say. And also Peter Liljedahl says that students get to work, or students get to the deep math much faster if we only verbally ask the questions. So we don't really draw, sometimes diagrams are necessary, but it's not a written question. So I'll say just that. There's a ball in a box, and I want to know how much empty space is in the box. And so questions start coming up. And students are already in groups at the board, and questions start coming to me like, well, like, how much of the box is empty? And I'll say, well, I don't know, but I can tell you that the ball is touching every edge of the box. So the box is as small as it can possibly be. It's a cube. And they're like, okay, so what are the dimensions? And I'll say, well, what dimensions do you need? And they said, well, can we have the dimensions of the box? And I'll say, sure. The side length of the box is 30 centimeters. And and they'll say, well, can you give us the dimensions of the ball? And I'll say, no, I think you have enough information. And then they'll go and they'll start working, and there might be issues, there might not. But the thing is, with just that little bit of information, students can solve this problem. And I think that that's really cool. And in the end, they think that it's really cool. So that idea of Peter Liljedahl's Building Thinking Classrooms is really spreading around the province, and I hope that you get to interact with it at some point, whatever school you land. It will come up in a later module. Okay. Oh, actually, I'm going to post a link here for my favorite task that I've done. It's actually part of my exam in grade 9. It covers about half the course, and the task centers, and it was done in groups, and people are at walls and they're working, and then there was a bit of follow-up reflection. But the task says, it gives a bunch of information about the 4 Tim Hortons cups and sizes and pricing and all that stuff. And I'll say that that's just not enough coffee for me, because my students all know that I drink lots of coffee. So I'll say that I would want them to design for me a cup and pricing for a double extra large coffee. Okay. And so students set off to that, and it takes a couple of days because it's some really big math. It is open-ended because the cups are not linear, so the students do have to make a decision at the end, right? But it's a really good task. I'm going to post the link for it here so that you can have access to it. And the last thing I want to talk about was the choice. I want to bring it back. I want to bring this module back to content knowledge for teaching. Because that snake task, the reason why I really like it is that the numbers are very well chosen for students to actually think proportionally. Right? So one of the snakes doubles and the other one doesn't, and the other one actually more than doubles, right? So we can talk about which one grew faster, right? Same kind of thing happened with the trees before, right? So we have to choose the numbers in order to invite proportional thinking, because a lot of people mistake cross multiplying for proportional thinking, and they mistake getting common denominators and comparing as proportional thinking, and converting to decimals or converting to percents as proportional thinking. All of those are calculations which stem from understanding proportional thinking, but they themselves are not proportional thinking. The thinking that one snake doubled and the other one more than doubled, because if it went from 120 to 240, then it would have doubled, but it actually went to 270, so it more than doubled, right? That's the proportional thinking that we want our students to be doing in grades 7, 8, even 9 applied, okay? What I wanted to say on that is that we have to have content knowledge for teaching in order to select those numbers so that students can use those sophisticated methods of discussing proportional thinking. Okay, that's all. I hope you enjoy your weekend, and we'll see you in Module 7.